Hi. So this is a presentation that I created for Texas Department of Agriculture originally, and I figured that it would be good to share it publicly as well. So this presentation is about reintroducing Castor to the Texan agricultural economy. So my name is Zach Alexander. I'm the owner of the Senn Sable company, and I'm just going to give you a bit of a synopsis here. So when we're talking about castor, we're talking about a non-food oil crop. This oil crop in particular is especially useful because it contains mostly ricinoleic acid in its fatty acids, and I'm going to talk about that later in more detail. But this crop is very suited for growing as a commercial component of Texan agriculture. It grows about 3 to 5 feet. The cultivated strains, the native strains, grow a lot taller, but the cultivated strains are very easy to grow. They grow in very undesirable conditions. Considering that most of Central and West Texas is now rapidly desertifying, it's going to be a great opportunity for those agricultural producers there to stay in the business. And I think that it's going to be even more prevalent as we see the effects of climate change. So here is a map of where castor is currently able to grow. Everything shaded green within those bands is where castor currently thrives. And you can see a number of countries around the world are growing castor commercially. The United States does not currently grow castor commercially, but we could. And you see that orange line there. That's where castor is eventually going to be commercially viable given the climate projections. So as we get closer to that 2050 climate projection, we're going to see that orange line become the de facto growing region for castor throughout the world. So there's a lot of untapped opportunity here in Texas and all across the world for castor cultivation. So this is kind of a rundown of what you can expect from harvesting castor materials. The seeds are, of course, the main component of harvest. That's where all the money is, and the main path here would be seeds, and then to oil, and then refined oil, and then the engineered materials. The engineered materials are where a lot of the revenue is planned for my company. But all of these byproducts have a home, and I'm going to talk about that in a second here. So when it comes to just seeds and a biomass from the field, that's not very valuable on its own, but knowing how many seeds we're producing and how much oil is in those seeds and how much biomass is produced by a particular cultivating strain is important for our company because we're able to determine whether or not our strains are economically viable and competitive. So of course we want to maximize the amount of oil, minimize the amount of biomass that's in excess, and so forth. And that's exactly what we're doing. Now, like I said before, all of the byproducts have a home. A lot of what is produced from castor processing can actually be redirected to the agricultural industry again through feedstocks. So cows are a major part of the agricultural economy here in Texas. Bovine production is a huge part of what Texas is known for. It's culturally significant even. And cows are unique in having 6 stomachs. Within those 6 stomachs, they're able to denature the toxic components within castor. So castor has ricin in it. It's been popularized on shows like Breaking Bad. A lot of animals will die if they eat large quantities of castor material. Cows won't. Cows are designed to be able to handle what they consume when it concerns castor. So that's a major opportunity just for feed production from the biomass derived from castor plantations here in the state. So that's something that I'm actually working with other bovine producers directly with. I'm trying to do research with a few of them. One of them is listed here. Other applications, of course, you can use biomass for just about everything that you would normally use biomass for. So pulp and paper, mulching material, all sorts of stuff. Now, here's the interesting novel use for biomass. Blue Biofuels is based out of Florida, and currently they're producing ethanol from biomass. They're using king grass, which is just a really large grass variety. King grass is kind of related to other woody materials in its composition. And castor is a very close alternative to king grass. It has a lot of carbohydrates in it. It has just a small amount of lignin, and so that makes it a potential alternative for king grass in their production. And so that's something that's just really exciting for me. And as that industry develops, very potentially, there could be a symbiotic relationship between the castor industry developing here in Texas and that ethanol production industry over in Florida. So here's the kind of the main revenue source for castor industrially. So from the oleochemicals that can be derived from castor, you can produce just about anything. Now, I want to base this presentation on three specific segments: the food and cosmetics, pharmaceuticals, and industrial products. And even then, the industrial products is very abridged. An easy way of thinking about castor applications is wherever you have a petroleum product, you could have a castor product. So everything from plastic to lubrication to pharmaceuticals to laundry detergent and other surfactant materials, to even the food that we eat and the water that we drink. I mean, there's a lot of different petroleum applications that people just don't even think about that they use on a daily basis, and all of those could be potentially substituted with castor. So what makes castor that versatile is the fact that it contains almost entirely ricinoleic acid in its fatty acid chains. So whether it's a plant or an animal, in the natural world, it is just about the standard to have a glycerol backbone. So that's what you see in the picture, the OR thing up there. That's a glycerin backbone. And then attached to each of those ORs, instead of it being OR, it will be O and then so forth from the fatty acids below. So what makes ricinoleic acid so unique is that ricinoleic acid has that hydroxy group deep into the fatty acid chain. Most fatty acids, like the ones you see below it, don't have any reactive groups deeper into the chain, whereas castor oil, ricinoleic acid does. There are other plants and a few other sources that have this kind of reactivity, but most don't, and almost none of them have the purity, the concentration of these components that we would need to make it commercially viable. So castor is just waiting for a major explosion in practical application. So some of the practical applications that you're going to see in your everyday life are deodorants, fragrances, cosmetics, chocolate especially. Just about anything that is chocolate coated anything has PGPR in it, which is derived from castor. PGPR stands for polyglycerol polyricinoleate, and it is essentially the result of taking that ricinoleic acid from the previous slide and manipulating it in one particular way. And you're going to see that's a repeating theme here. There are a lot of other compounds that can be produced from ricinoleic acid, but PGPR is already recognized as food safe, at least some of the different compounds related to it. And others can be used for cosmetic applications and even lubrication and surfactants themselves. A lot of different crossover applications there. And beyond PGPR, you have sodium ricinoleate, we have hydrogenated castor oil, and we have other things that we can apply into the foods industries, cosmetics industries, consumer product industries. So it's just a really untapped resource there. Now, when we're looking at the more industrial applications, a lot of the different, lubricants, paints and primers, polymers, they're all manipulating that same chemical pathway using ricinoleic acid. It's just manipulating them in other ways. Now, all of the companies listed here currently have their own form of manipulation of ricinoleic acid. Not all of them are doing the exact same thing, but a lot of this chemistry is really quite similar. And that's the great thing about castor. You can just slightly tweak one process and get an entirely different branch of derivative products, which just opens up the possibilities for applications outside of these industries that we haven't even considered before. And so I'm just incredibly excited to see Castor produced and processed here in the United States, and especially here in Texas. Of all of these companies, and some of them are actually based in North America, many of them are not American based, however, and the ones that are American based, you see here, Arkema is based here in Texas, but their Castor production facilities are over in Singapore. Biosynthetic Technologies is the only company I found so far that is based in the United States and processes those materials right here in the United States. So it would be great to see a Texan castor processing company processing Texan grown castor. I think that would be a game changer, and that would set the standard for castor derivative production moving forward. So here's kind of a more visual approach to explain what those companies are doing, because I know if I just talk about estolides or surfactants or whatever, most people are going to tune out. But this is a little more easy to digest. So looking at polymers, that's going to be Arkema. They produce a compound, it's pictured here, called polyamide 11. Their brand name is Realsan or Ralsan. I'm not really sure how to pronounce it, but polyamide 11 is just like nylon 11 in its application. And so all of these pictures you see attached to that, the picture of glasses, those are Ray-Bans. The shoes, those are On shoes. And then the helmets, I can't remember how to pronounce that helmet brand, but between helmets, shoes, glasses, all of these things are made with polymers derived from ricinoleic acid that comes from castor oil. So there are a number of benefits to this kind of plastic. For one, it's biodegradable. So we're all talking about microplastics. You have microplastics the size of a disposable spoon in your head, apparently. That's really scary, right? One of the things that we can do to try to mitigate that is use biodegradable plastics like these. These plastics, when they get to that microplastic size, there are bacteria spread all across the world right now that can break down those compounds. So instead of building up in our bloodstream, they get broken down and are deposited back into the soil as nutrients that can be turned into more castor if they end up being within a field of castor. So, it's great that we're able to full cycle, cradle to grave, have control over that material. And that's something that we don't have with petroleum-based plastics. Carrier agents, that's going to be Arkema, or not Arkema, Albert Inc. Bully. And they produce all sorts of different castor-based paint and pigment compounds. But one thing I wanted to point out was grout here, which is the stuff that you use to plant tiles where they're going to be, whether on the floor or in, on a wall in a bathroom or something. That grout can be modified with polymers from, Arkema or whoever, using a carrier agent from Albert Inc. Bully, and both of those can be based on castor. The polymer in the grout makes the grout stronger, cheaper, and faster setting, which, we all know that there's a housing shortage here in the United States. The fact that you can build these houses with grout that is cheaper, that sets faster, and is stronger overall is a great improvement for everyone, because that means faster production of houses and cheaper production of houses, which we all need. So I just thought that was a really cool application there. Now, the pills at the top here and the flower at the bottom, those represent pharmaceuticals and colors and fragrances, respectively. Now, if I wanted to go into a whole segment of all the myriad different applications there, we'd be sitting here for hours. But the takeaway is castor, the ricinoleic acid, can be manipulated to do all sorts of things. For instance, pharmaceuticals could really benefit from drug delivery devices derived from ricinoleic acid. Just like I was saying that you can manipulate the chemistry there, you can force ricinoleic acid to form kind of a ball structure, and that ball can make certain drugs that are currently being administered intravenously available for over-the-counter administration orally. And that would be a great improvement. So think about all the drugs that you currently have to go to a doctor's office and get, something piped into your veins for. Instead of having to go and do all that and all the extra costs associated with it, you could take a pill over the counter, and then when the drug enters your stomach, instead of the drug being destroyed in the stomach, which is usually the reason why it has to be delivered intravenously, it'll be processed through the stomach with this ricinoleic acid coating. And then once it gets to the bloodstream, that coating falls off, it degrades, and you're left with the drug that you were trying to get to the bloodstream in the first place. So it's a great improvement. It would be a cost effective way of getting a lot of intravenous drugs into the bloodstream for a lot of patients. And we need more cost effective means of drug delivery if we're ever going to address this, health crisis in our nation right now. Colors and fragrances, a lot of the same story. You manipulate the chemistry and you get all sorts of things. And just like with previous, the fact that it's not petroleum based, petrochemical based, you're able to get a lot of these noxious, potentially dangerous compounds off the market just because Castor's better, cheaper, and, just generally available. Now going to estolides, this is really cool chemistry. So ricinoleic acid, that's the main player here. In this case, ricinoleic acid is being stacked on top of itself, kind of like a staircase. And so if you can imagine a molecular staircase of ricinoleic acid, it forms what is essentially a platelet. And that's great for lubrication. Synthetic additives are often lubrication additives that force metal components apart. You don't want metal touching metal when you're trying to lubricate. And when you form a platelet like this, the platelet wedges itself in between the two surfaces and prevents wear of those metal surfaces against each other by absorbing that friction. So the different kind of platelet you produce determines the different viscosity, temperature, and other profiles of that lubricant. And so Biosynthetic Technologies produces all of these that are pictured here. This comes off of their website. And you can produce everything from motor oil to gear oil to hydraulic fluid and even like grease, industrial grease, which is really cool. Now, my focus here when it comes to estolides is not so much to produce the entire feedstock, which is what they do. They use Castor for everything. Instead, I would be more interested in using these platelets, these estolides, in a conventional feedstock. So instead of using crude oil derived lubrication additives, we could use castor oil derived lubrication additives with a crude oil base stock. And so what that would allow us to do is to extend our crude oil resources much farther into the future than we're currently projecting. Right now, we are running out of crude oil resources here in the United States and within our control. And that's a major issue. A lot of what we use in our daily lives comes from crude oil. When we run out, we run out. So if we can extend the resources we have right now by adding castor to the mix, that would be a great improvement for everyone that uses crude oil right now, whether commercially, industrially, or just in the consumer space. And then lastly, of course, PGPR, that's kind of a stand-in. Like I mentioned, there are a lot of different food and cosmetic additives, but PGPR is just the most well-known one. And I thought it was kind of amusing. I went to the store, recently going to the grocery store, I went and I looked around, I looked for products that had PGPR in them, and I found all of these products on the shelf. So it's really cool to see it in actual practice. If you go to any store, you pick up a Hershey's bar, you're going to be picking up PGPR. If you buy Olivio, certain products that they produce, their buttery spreads, those have PGPR in them. If you buy certain confectionaries and baked goods, those are also going to have PGPR. And then, of course, cosmetics, there are a number of cosmetics with PGPR. So it's just really cool to see it in practice. And I know that as time continues, more adoption of castor-based derivatives is inevitable. So here's a little bit about me. So my name is Zach Alexander. I'm the owner of the Senn Sable company. And I have 3 different segments here that I am focused on. Like I've been mentioning, PGPR is a big part of what I want to be involved with here in the States. And so Soarin' Foods is my food additives and foodstuffs branch of the company. And then Aerosen Personal Care, that's eventually going to evolve into Aerosen Pharmaceuticals because I want to do a lot with the pharmaceutical development there. And then Arcane Energetics. And so the Arcane Energetics segment is actually based on a byproduct. So you'll remember from a previous slide, I talked about how you broke the ricinoleic acid and other fatty acids from a glycerin backbone. Well, that glycerin is a waste product, but it can be reprocessed into something like nitroglycerin, which is a far more valuable product. That's a value added product, so to speak. So it not only is it really cool, it's energetics, high explosives, very cool industry, but also it's taking full responsibility for the material, you know, not just taking what I want, throwing the rest away. It's actual application for all of the different compounds from the material, which I think is just really cool. So if you got something out of this presentation, great. I'm excited for you. If you happen to want more information, feel free to shoot me an email, give me a call, whatever you want to do. My contact information is right there. And I hope that you're as excited about Castor as I am.